Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based, of course. And as always, it is an honor and a privilege to be serving you, as it is every day in my virtual classroom. Here, I'm going to get you some solution guide stuff for graphing out of Slope-Intercept Form. I might have some videos on it that I made last year or in old times, but I know there are no lecture videos on it really, outside of just one little bit and showing y equals mx plus b. I'm going to do some with you on these graphs. Not a big fan of the graphing windows that they give me because they go up by 2s on both x and y. As long as they do it on both, it's not an out of this world terrible concern. I might show you on one version what it's like without going by 2s and just going by 1s. That'll be fine for me. But I got 8 problems for you to do. Write each equation in slope-intercept form. Identify the slope and y-intercept, then graph the line described by the equation. Now with this, we will be doing it without a table, in that there is a shorthand approach that at least I taught my class that most people do understand. With this slope-intercept form, we're talking about y equals mx plus b, and in this case, it actually does reveal for you the letter m does indeed represent the slope of your line, how much it rises or falls, but I'll put rise, over how much it runs. The b value here is your y-intercept. I shouldn't write b right next to that. I should say y-intercept, and that always occurs at the value when x equals 0 and y is whatever it is, 0 comma b. It can also be negative. Keep that in mind as well. And this process, it's 3 steps. Well, there's some steps before that. If you're not in slope-intercept form, your step 1 is to get it in slope-intercept form. Your graphing steps, though, when you're in slope-intercept form and you've identified your slope and y-intercept as your m and your b, is step 1, you start with the y-intercept. You start by plotting your y-intercept. So on number 15 here, I'll get started. Y equals 2x plus 3. This is in that slope-intercept form. I have y equals mx plus b, y equals 2x plus 3. The m is 2. I'll show you what I'm going to write with that in a second. And the b is 3. I'll show you what I'm going to write with that in a second. If step 1 is starting by plotting the y-intercept value, I want to know exactly where this location is. Some people might accidentally, by the way, these go by 2s. So the 2, 4, 3 is in between there, and 2, 4, 3 is in between there. Some people might think you plot it right here, but that's the x-intercept. Some people might think you plot it at 3, comma 3. Oh, that's neither intercept there. The y-intercept is at 0, comma 3 right here. It's pretty nice if you instead write 0, comma 3 to make sense of the fact that's where you're plotting. And we want to begin right here. When x equals 0 in this equation, 2 times 0 plus 3 is 3. X equals 0, y equals 3. That is a nice constant, no pun intended because this is a constant. It's a nice constant beginning on these problems here. I don't like that they start off with this problem that's between these marks right here. The slope is what we use next. We use this slope and it can be written as a fraction. I'm going to rewrite 2 as 2 over 1. The reason is because the slope is all about how much you rise compared to how much you run. And 2 is 2 divided by 1. So I'm giving it its fraction equivalent. This allows me to know that every time this graph rises 2, it also does run 1 over. So I could go up 2. Here's 3, 4, 5. That's going up 2 and over 1. Again, not a big fan of the idea that they're not giving me all the nice little crosshairs here. Going up to 6, 7, over 1 to 2. That's another point that exists on this graph. And I'm going up and right because the slope is positive. Positive 2 is a rise. Positive 1 is a run to the right. Rise 2 more, 8, 9, and over 1 more here. And I can't really fit any more points going to the right on this graph, at least because when I go upward, I run off the map. So these are nice points to fit on here. For my students, I'm always going to ask them to fit as many points as they can plot, in which case we should go to the left. That's a negative 1. Did I just change my slope? Sort of. I need to make sure the top is negative as well. Negative 2 divided by negative 1 is still a positive 2. That makes me go down 2 as I go left 1. So as I continue on this path here, it looks like down and left continues the positive trend. 2 negatives do make a positive when you multiply or divide them. If I go down 2 and left 1 right here, that's another point that exists on my graph. This is completely without a table. In fact, I'm not even mentioning what these actual ordered pairs are. This actual ordered pair, let me go down 2 and 1 more. This actual ordered pair right here is the point negative 3 comma negative 3. I never once mentioned that. Personally, I'm not as concerned about that unless they ask me about it. I'm just concerned that I get the points, not that I identify them. every time I'm going down 2, left 1, just like this, down 2, left 1, down 2, left 1. And again, for my students, I want them to fit as many points as they can on this graph. What I don't like about this graph, one more time with the scale, is that it almost treats them like these are fractions because they're going in between these grid marks. They're never actually hitting any of these other, points here. So this is not my favorite example to start off with. I'll mention something about this that makes it slightly more simplified, but really it would just be a lot nicer if they didn't go up by 2s on these graphs, especially when you started with an odd number. Anyway, you connect the dots because all these functions will be continuous. Actually, they're not always functions, but all these equations will have continuous graphs. And we draw arrows to imply that the domain of all real numbers is actually being applied. Every point on this line exists. We just found some that were easy to find by counting up 2 over 1 or left 2 down, down 2, left 1, something like that. But that is the graph. There's nothing to solve for. This is an infinite number of solutions. When x equals this, y equals that. When x equals this, y equals that. When x is 100, y is 203. These go on forever. And this graph represents that. It is linear. So the step 1, once again, was start with the y-intercept. Step 2 was use your slope to get more points. And step 3 is connect the line, draw the arrows. That's number 15. Number 16 here, y equals negative x plus 2. Once again, this is in slope-intercept form. It might be a little less obvious on m, though. So let's start with b. The b value is a 2, or that means 0, 2 when it comes to y-intercept. We will actually start right here. And then we're going to use the slope next. Now, the slope m, we got to figure out what number's multiplying with x. That's kind of what we're asking. There's a negative attached to the x, and when you don't see the number, it's implied that it's a 1. So your slope is negative 1. Now, as a fraction, because that's what we want, negative 1, of course, divided by a positive 1 still gives you negative 1. So writing it as a fraction, once again, reemphasizes the idea of down 1 over to the right 1. And that's what I'll do here. Now, what I'll start with, and you might go like, oh, again, is because this is at 2, and this is 0. So when I go down 1, it's right in between, and right 1, it's right in between right there. That's one of my points. The next point, if I go down 1 to 0 on y, I go over 1 to x on 2. There's another point. Now I'm going to make this one a little bigger because I want to show you kind of a shortcut here. A student asked me this in class, and the answer was yes. The question was, Mr. Robinson, do the scales actually matter, or can you count even with the bigger scales on these things and still land on points on your line? In other words, instead of going down a real 1 and over 1, can I go down a whole hash mark down to 0? Even though I actually went down 2, can I go down 2 and over 2 and still be okay? The answer is actually yes, you can. So for me, remember, down 2 over 2, down negative 2, right positive 2, negative 2 over positive 2 is still a negative 1. This is an unsimplified version, but for the sake of my scaling that's doubled right now, it might be nicer for me to just go down 2 and over 2 each time. I will say down 1 over 1, not by scale, going by the drawing. Down 1 whole hash to here and over 1 right here. Even though I'm actually going down 2 over 2. But the slope is still the same, right? If I down 2 burgers in 2 minutes, on average, I downed 1 burger a minute. So that's the idea. Hey, another 2 burgers in another 2 minutes. That's probably not what this would be as a word problem here. And I'm going to go as far as I can fit my points to the right, and I will continue that to the left as well. Now, because this was a negative 1, I was falling 1 because my 1 on top was negative. That's my rise or fall. My run was to the right. But I can make this positive as long as I make this negative here. 1 divided by negative 1 is still negative 1. So now I can rise 1 as I run left 1. Remember, it's 2, really. 2, but up 1, left 1, and it continues on that path here. Up 1, left 1, and so on. So I am skipping the points in between, even though those are actually integers. They feel like fractions to me because it's in between. To me, this sounds like a half and a half. And I'm not a big fan of that. Most people aren't. You want to get points that are identifiable and enough that kind of validate it. And I want my students to always plot as many points as they can fit in their graphing window. So for me, these were quite a few points. I think there were 10 total right there. They could fit, and there's the line. Negative slopes fall as you run right. Think of it like, money, like you're losing money. Oh, as time goes on, I'm losing money. Negative. Doesn't necessarily mean bad. In some cases, you could lose weight, and that's a good thing. Or you could close in on distance toward, home or something like that, and that's a good thing. Just negative is just the direction. Not that it goes down, because they all go down. This one goes down, see? But that goes down as you go left, which means it goes up as it goes right. That's positive. This is negative. So anyway, pulling out the information, drawing the slopes, getting the y-intercept stuff's good there. Now, the reason why I didn't mention that 2/1 right here is because it already started on a fraction on this one. So if I were to go up to 1, 2, I'm still at not a real fraction, but I'm still at a halfway point between my marks anyway. But up 2/1 right here would have looked like this. Yeah, I would have saved a step. I just didn't feel like it was as good of a time to mention it on one that was already at some halfway marks there. And down -2 over -1 would have gotten me there from here. So anyway, you can use that on those as well, but again, because it was already odd, it was, whatever. When I hit number 18, guys, I'm going to change the scale, so these aren't 4 and 8. That's going to be a 2, and it's going to be 1, 2, 3, 4, 1, 2, 3, 4. By the way, I just mentioned here before, because what the student asked me on this last one, sorry, I promise I'll move on next, is can I go down and over as long as the scale is the same? And the answer is yes, as long as the scale is the same. Let me switch to another page for a moment. I guarantee you a word problem will change the things. Perfect, right here. So look at this problem right here. Notice that the scales are different. Every one increment, x's go by 1, y's go by 10. So let's say I had a slope of, 10. Sorry, let's just say, sure. Let's say 5. Let's say I had a slope of 5, which is 5/1. From here, I couldn't, and I don't know if this, actually, I think the slope is 5 here. That was just made up. But for 5, I couldn't go up 1, 2, 3, 4, 5, and over 1. And then you go, well, Mr. Robinson, you said the scale doesn't matter. No, if they're the same, you can treat it like that. Because I didn't just go 5/1 here. I went from 50 to 100. You know how much I went up? I went up 50. And I ran not 10, I just ran 1. My slope I just drew was 50/1. If I want to do 5/1 here, I got to understand how it's working with my scale. I can't just count on y because every one of these is really 10, whereas every one of these is really 1. So there's just a big difference between the two. So up 5 is up halfway and over 1. And I guess that's what this slope is. I was just kind of making that up, but this is an up 5/1 in and of itself. So if the scales are different, you got to pay attention to the scales. If these were 10 here, sure, I could go up 50 and over 10. That's still 5. That works. So if the scales are the same, you can do that count, which these one scales are the same. Just sucks that they're all 2s. All right, number 17, y equals 2/3 x minus 4. Do not be threatened or intimidated by the slope being a 2/3. We're just counting the rise and the run. In fact, it's already written as a fraction. I actually prefer these to the integer ones because I already know what the fraction thing is. The y-intercept is -4, so I'm starting at 0, -4 right here. So that is this guy right here, 0, -4. And now I'll use my rise and run, positive, and go up right. Remember, if by normal scale you would just go up 2 over 1, 2, 3, you can save that. Why don't we go up 1, 2, and over 1, 2, 3? Yes, I really did just go up 4 over 6. But 4/6 does reduce to 2/3. By the scales being the same, by the power vested in me, I now pronounce this a linear equation. I can go up to another 3. This is something that does fall off the graph. It's kind of up to you if you want to fit that one. I like it for just verification that it's just looking good. I know that from one endpoint all the way to the other one, I get a more accurate looking line. And down to left 3 because negative divided by negative is a positive. Down 2 from here, left 3. Let me go another down 2 and left 3. Even though it's off, this one might be a little harder to judge. I think that one's there. If you only get these 3 points there, no biggie. If you want to get the ones in between, a real down 2/3, sure. You're not going to see me do it very much. I might stop doing those unless it's just kind of a requirement. And there's my line. My lines do have small arrows by my tool. But I always like to draw them bigger because sometimes people can't tell or they don't notice that that's another part that's happening with it. There's my line. How beautiful. How sweet. No tables. No tables. Understanding the process is one thing. Understanding what's actually going on is another. And I'll save the what's actually occurring here. But if you do it with the table, you might realize the constant change in x gives you this constant change in y. All right, y equals -1/2 x minus 1. Can we please get rid of these scales here? Oh, so beautiful. It's gone. There it is. Just ignore these completely. Just pretend like everything was a 1. Going up by 1s. The reason why I'm doing it for this one is because that y-intercept is odd. For any y-intercept I find that's odd, I'm going to be doing that. That okay? Sure it is. Probably spending more time doing this than just playing with the fractions, though. Now each of these is a 1. That's 1, 2, 3, 4. You can ignore those. I know you can kind of see them, but... Oh, there's another one. There's an 8. All right. There we go. It looks good. All right. My y... Let's see what color I haven't used. Let's use this one. My y-intercept is 0, -1, and my slope is -1/2. Now look at how it's typed. The negative is in the middle of the fraction. Mr. Robinson, does that matter that's in the middle of the fraction? No, but you do need to know how negative direction works. Negative direction is down and right. Do not apply this as if negative goes to the 1 and negative goes to the 2. Remember, that's a positive. If you want to treat it as, do I go down or up first? I would definitely go right first if you can. So I like to say that numerator's negative while the denominator's positive. -1 divided by 2 is -1/2. The negative only goes to one fraction value at a time, numerator or denominator. You don't have to write this stuff. This is a perceptual kind of... You're obtaining something in a perceptual way to make sense of it. So starting for the y-intercept of 0, -1. Remember, that's just -1 now. I can go down 1 as I go right 2. So down 1, right 2. Boom, there's a point. Down 1, right 2. Boom, there's a point. Sometimes you'll see me like make a slope triangle like you saw before. It helps some people to make them. Makes it more confusing for others. If I... Like that. If I fall 1 and run right 2, then I can also rise 1 if I go left 2. Rise 1, run 2 to the left. So up 1 over 2 right there. Up 1 over 2 right there. You can see I'm not going to go 2 this time. It falls off the graph. Whatevs. We're good. Let's connect this guy right here. There is a beautiful line. Goes through all my points. There's a nice slope triangle within there as well. Not required. Kind of paying attention to the idea. Don't miss... so here's the funny thing. You guys will actually end up doing rise over run so often that when you see a point, something like 4, 1, guess what a lot of people do? They go up 4 and then right 1 and plot the point. Be careful. This is X and this is Y, right? So if you ever have a point 4, 1, you got to plot it. You still got to go right 4 and then up 1 like that. Even though rise comes first in this scenario, rise and fall comes first, the y comes first. So slope, the reason why slope works this way is because you want to say how steep does your line get, and the larger the value, the steeper it is in that form. I still have 4 more problems here. I'm going to try and get them done in about the next 12 minutes or so. But for these next 2, at least, notice we're not in slope-intercept form. That means -4 is not necessarily my slope. 10 is not necessarily my y-intercept. In fact, I'll tell you right now, they're not. I got to get y by itself. To get y equals mx plus b form, I need the x term over on the other side, the constant on the other side, which it is, and then y all alone, no coefficient. So I'm going to start by adding 4x to both sides like this, plus 4x plus 4x. Now on the left side of the equation, I have 2y, but on the right side, I have a 4x and a positive 10 being added. Notice I'm trying to write the x term first to match up here, and then the constant after. So even though it was 10 plus 4x, which don't combine, I'd rather write 4x plus 10. Now I'm going to divide both sides by 2 because I got to get y by itself. And when you divide by 2, everything divides by 2 here. So y is all that remains here. 4 divided by 2 is 2, and 10 divided by 2 is 5. This is my slope-intercept form for this guy, y equals 2x plus 5. See, I told you your slope wasn't -4 and your y-intercept wasn't 10, and there it is. Because this is an odd... Is it okay if I treat these as just the numbers? Hopefully who are watching, those who are watching or listening to, this is really going to be a 2 and a 4, okay? I'm going to go up by 1s, 2 and 4, because this is odd. I don't want to play with that really right now. So I'm going to start at, and for this one, maybe it's not as good that I'm doing this, because I got to start at 1, 2, 3, 4, 5. I got to start all the way up here. Sorry. I guess maybe I won't do that each time. But this is 0, 5. That is my y-intercept here. My slope, remember, is a positive 2 over positive 1. Now, I'm at the highest point that I can possibly fit in my window because of my scale change. So rising 2, running 1 is probably not very fun because this is off the graph. Instead, I should do my fall 2, run 1 to the left. Negative divided by negative is a positive. As this goes up and right, this also does go down and left. So let me fit the points on the other side here. Down 2, left 1, there's a point. Down 2, left 1, there's a point. Down 2, left 1, there's a point, etc. We keep going, and these are all the points I can fit on my newly made graph, because I made it differently here. So there it is. That is still y equals 2x plus 5, even though the only direction I could see on mine was negative. Maybe next time I will leave the scales in there. Maybe next time they give me one that doesn't have an odd number thing with the scale, they work better on it. It'd be nice. All right, number 20. Same thing, not yet in slope-intercept form. Let's get it in there. Let's subtract 3x from both sides, and be very careful on a couple fronts here involving the negative 6y. Don't just turn it into a 6y. It's still negative. I have a negative 6y equals. Now there's a negative 3x I want to write first here, and don't write plus 12. Notice the 12 is negative. We will be subtracting 12 as well. We're not done though. We're not yet in slope-intercept form because y is not by itself. So I'm going to divide everything by negative 6, and a negative divided by negative, as we mentioned over and over, is a positive. Every term, awesomely, becomes positive here in the end. So now I'm going to have positive 1y, which is what I need. Negative 3 over negative 6 is positive, and I'm going to reduce 3 over 6 to 1 over 2. Yes, you do reduce your fractions here when you can. Divide top by 3, bottom by 3. I get 1 over 2. Negative 12 divided by negative 6 is positive 2, so y equals 1/2 x plus 2 is my y equals mx plus b slope-intercept form, or my slope is my rise over run, 1/2, and my y-intercept is at 0, 2. All right. For this one, I will keep on the even things because it is a 0, 2. I'll just go up to 2 right here. Looks good. And now when I rise 1, run 2, I don't have to go in the inner bits right here. If you want, you can just go up 1, which is really up 2, over 2, which is really over 4. Remember, 2 over 4 is the same thing as 1/2 as well. If they give me these scales, might as well play with it if it's nice enough. Up 1 over 2 again, because it was a positive slope, I go up and right. And let's continue in this direction down and left as well. Down 1, left 2. There are a lot of students no matter how many times I really try and emphasize it, and I'm not blaming them. I'm always trying to find out a way that I can show it more and more. But students to this day will always, no matter how many times I teach them or tell them or try and help them out, and they even say the right thing, they'll always see down and left as negative. For whatever reason, they will. It's not, because both are negative. It's me saying yesterday I had this many less dollars. In the positive realm, today I have more. Just because I had less doesn't mean it's bad if it was yesterday. There's my graph. 2 more graphs. Ready to boogie? Here we go. Numbers 21 and 22, once again, we must get y by itself. And let's proceed. Add 5x to both sides here. And once again, that 2y that is negative must stay negative for now. So I'll have negative 2y equals positive 5x plus 8, as the 8 is positive. If there's no negative sign, it's positive. That means we'll be adding it. So I divide both sides by negative 2, which again is every term. Be careful. Some people just divide this 8 by negative 2 and not the 5. Everything's dividing by it, the whole thing. It really should start off as just 1 divided by negative 2 like that, and then common denominator says we get to split that up. So here we go. So negative 2y over negative 2 is positive 1y. Now I got a negative 5/2 slope, negative 5 over 2x, and 8 divided by negative 2 is negative 4. So negative 4 minus 4. Once again, depending on how you write the fraction here, I will write the slope as the negative 5 divided by positive 2. So I go down 5, right 2. And my y-intercept is 0, negative 4, right here. This one is not as helpful to go down 5, you'll see, even if I have these going by 2's here at 0, negative 4, where I start. Going down 5 and right 2 literally runs into these guys here. So maybe for this problem, I'll go down a real 5. That means negative 5, negative 6, negative 7, negative 8, negative 9. That went down a real, whoops, don't plot it there. But that will go down a real 5, and over a real 2 is 1, 2, right there. That's me fitting it as if I actually go down 5 and over 2, as opposed to 10 and 4. Here I could go up 5, 1, 2, 3, 4, 5, and over 2. Boom. Like that. Or, because to stay consistent, 1, 2, 3, 4, 5, and left 1, 2. There's that in-between point. I think those are really the only ones I can fit. Those are the only ones I will fit. All right. Oh, such a beautiful graph, such a beautiful graph. I'm having a laugh. 'Cause I'm doing math. Got one more problem to do with you guys. Hopefully you're clicking with this still. And every so often, I like the progressive build of these problems. I do like that they're throwing in another little wrinkle each time. I don't think this one has much of a wrinkle here. I stated that I don't mind my slopes being fractions. You know what I do mind being my fractions are my y-intercepts. Those are no fun, because now you got to start on that fraction. It's not about a rise and run right there. All right, negative 3x minus 12. So if I can divide everything by 4, a positive 4 here, it looks like I'm going to be getting y equals negative 3/4 x minus 3. Negative 12 by 4 is negative 3. So my slope is negative 3 over 4. My y-intercept is 0, negative 3. For this one, because it's odd, can I still fit down there if I go 1, 2, 3? Okay, we'll play by their rules this time. 0, negative 3 is right here. I'll go down 1, 2, 3 over, whoops, I did that. 1, 2, 3 over 1, 2, 3, 4 to the right. Remember, negative slope is down to the right. And down 1, 2, 3 over 1, 2, 3, 4, like that. Up 3, 1, 2, 3 at the origin, right or left 1, 2, 3, 4. And up 3, 1, 2, 3, left 1, 2, 3, 4. So again, the in-betweens are because we're going by 2s on the graphs. Not a fan of them. I'm hoping next time that I do graph things, I'll provide different kinds of graphs for you, or they'll provide different kinds of graphs for you, so they don't do that. There's no reason for them to do that, especially when in the examples they had, they never did this. I don't know why they started to be cruel for you kiddos and do that there. Anyway, those are the graphs. Those are all 8 graphs right there. Never once used a table. Only calculations I ever did was counting, really. And if I do another video down the line, we'll talk about writing something in slope-intercept form given information, maybe given the graph. Can we write in slope-intercept form, because we practice finding the slope in that bit as well. So I hope that was useful for you guys. If you have any questions, leave it down in the comment section below. All right, take care. Thank you.